Now that we have the basic structure down for hypothesis testing, namely, we're going to make statements regarding the nature of the population, we're going to collect evidence, and then we're going to analyze the data to assess the plausibility of that statement. So once we have those 3 steps down, you can see that that statement that we make in that first step is going to be very important to us. Those are our hypotheses. So we're going to become very formal about how we write hypotheses. Namely, you're going to have to write 2 of them. So you're going to write a null hypothesis and an alternative hypothesis. The null hypothesis is what you assume to be true unless you can prove otherwise, just like in the game of Clue, if you ever played that board game as a child, or as an adult for that matter. So it's a statement of no change, no effect, no difference. We assume things are what we thought they were. The alternative to that is claiming that there is some kind of change to the population parameter. And of course, these are always about the population parameter because that's the unknown thing. And remember, there are 4 options for us for a population parameter. P, the proportion, mu, the mean, the population variance, which is sigma squared, or the population standard deviation, which is sigma. The last 2 of these, of course, are basically the same thing, right? It's just one is squared of the other. All right, so a hypothesis test, when we run them, is sort of like a trial. You start by, and I mean that by like a jury trial, right? You assume the null hypothesis is true. You assume something about what's going on. And then you try to prove or provide enough evidence against that null hypothesis to reject it, right? So you're trying to sort of prove the alternative if you can. All right, now there are 3 kinds of tests. And I have some examples over here for you. There we go. So we're going to have examples of each one of these. Now notice the left and right-tailed tests are called one-tailed test. And then two-tailed test is a two-tailed test, right? So both left and right are types of one-tailed tests. The only types, as a matter of fact. Okay, so we have a right-tailed test where the parameter is equal to some value or the parameter is greater than some value. And this is sort of what we were doing with our dice, right? We assumed that the dice were fair, which means the probability of a 5 is 1/6, unless we can prove it otherwise, and that it was loaded, it was greater than a 6th, right? Because of course Steve rolled so many of them, that would indicate perhaps that's where we're going with that. All right, what about a left-tailed test? Well, most people assume, incorrectly, by the way, that the average body temperature is 98.6 degrees Fahrenheit, right? So in the US, that's kind of the standard, oh, people have a body temperature of 98.6. But if you do some research into it, you might find that a lot of people want to argue that it's less than 98.6. Right, closer to 98.2 in fact. And so that would be a left-tailed test. If you try to prove that, you're taking what people assume to be true, 98.6, and you're going to argue less than. That's a left-tailed test. And then the two-tailed test would be equal to or not equal to. So I'm just going to make it up, right? So I assume sigma is equal to 3 for some, standard deviation. Like I give a quiz and I tell you, the standard deviation is it should be 3. And the alternative for that would be that it's not 3, it's something else.